Have you ever wondered how machine learning models, those invisible brains behind many of today's technological marvels, are built and selected? This enigma envelops a process that is both fascinating and complex, yet it can be simplified into manageable steps. Start by imagining a machine learning model as a recipe. Just as a recipe requires ingredients, models require data. This data can be anything from customer reviews to satellite images, as long as it holds valuable information. This is the first step, collecting and preparing data. But data, like raw ingredients, isn't useful on its own. It needs to be cleaned and processed. This involves removing irrelevant information, filling in missing values, and transforming data into a format the model can understand. This second step is called data pre-processing. Next, we have the main event, cooking, or in our case, training the model. This is where we introduce our algorithms, from regression that predicts continuous outcomes, to classification that categorizes data, to clustering that groups similar data, and ensemble methods that combine multiple algorithms for better performance. These are the chefs of our recipe, each with its own speciality. Choosing the right algorithm depends on the problem at hand. For example, if you're predicting house prices, you might use regression. If you're sorting emails into spam and not spam, classification is your go-to. But how do you know if your model, your recipe, is any good? This brings us to the fourth step, model evaluation. Here, we use metrics like accuracy, precision, recall, and F1 score to measure the performance of our model. Accuracy tells us how often the model is correct. Precision tells us how relevant the model's results are. Recall tells us how many relevant results the model can find. And the F1 score balances precision and recall to give a single performance score. But remember, no model is perfect. Just as every chef has a bad day, every model can make mistakes. That's why the final step is model optimization, where we fine-tune the model to improve its performance. This could involve tweaking the algorithm parameters, adding more data, or even using a completely different algorithm. So there you have it, the process of building and selecting machine learning models, broken down into 5 simple steps. Collect and prepare your data. Pre-process it to make it understandable. Choose and train your algorithm. Evaluate the model performance. And finally, optimize your model to make it the best it can be. Whether you're a seasoned data scientist or a curious observer, understanding these steps can help demystify the world of machine learning. So next time you marvel at a recommendation algorithm or a predictive model, remember the intricate process that goes into creating these digital masterpieces. They might be invisible, but their impact is undeniable.